Hello everyone, welcome to Science Solutions with Karishma. This is the part 5 of the chapter Rational and Irrational Numbers of ICSE Class 9 from the Concise Mathematics SELINA. And in this video, we are going to solve the remaining questions of exercise 1B from questions 13 to question number 20. So let's get started. So the next question in exercise 1B is 13. Write in ascending order. Ascending means we have to arrange them from smallest to largest. So, among this number, we have to find which one is the smallest and which one is largest. And in the case of descending order, it's just opposite of ascending, that we have to first write the largest number and the smallest one. So here we'll write first the smallest, then largest. So question number 1 is 3 root 5 and 4 root 3. We can write 3 root 5 as, since it is the square root, so 3 has one pair. 2, 3 will be inside the root. So we can write 3 root 5 as 3 into 3. It will come inside 3 into 3 and 1 5 is inside the root into 5. In the same way, we can write 4 root 3 as 4 into 4. There will be 2 4 inside the square root. 4 into 4 and 1 3 into 3. So we'll multiply it. 3 3 is 9, 9 5 is 45. And here we'll get 4 4s are 16. 16 into 3 is 48. And here 45 is the smallest and 48 is the largest. So the ascending order is root 45. Ascending order is root 45 and root 48, lesser than root 48. Next, question number 2. 2 into cube root 5 and 3 cube root 2. Here it is cube root. That means inside the root there should be 3 numbers. That is, there will be 3 2 and inside the root there will be 3 3's. So we can write it as 2 into 2 into 2. And 1 5 is inside into 5, and we'll have 3 into 3 into 3, and 1 2 is already inside. So here we'll get 2 2s are 4, 4 2s are 8, and 5s are 40, and 3 3s are 9, and 9 into 6 is 54. So 40 is smallest, 54 is largest. So the ascending order is 40 is less than 54. In the similar way, you will solve the next question. Question number 4. Question number 3. Since it is the square root, you can write it as 6 into 6 and 1 5 is inside. And here it is also square root, 7 into 7 into 3. Next is also square root. There will be 2 8, 8 into 8 into 2. You'll multiply all these and you'll solve. This is your homework. Next, question number 14. Write in descending order. As I've already told, descending order means you have to write largest number first and then the smallest. So let's do question number 1. 2 4th root of 6 and 3 4th root of 2. 4th root means there should be 4 numbers inside. 1 2 3 4. 4 same number. 2 into 4 root 6 means there are 4 2's inside. So you can write inside the root there are 4 2's. 2 into 2 into 2, and 1 6 is already there. So 4, 2 and 1, 6. And you could have written 6 into 2 into 3, but since it is a fourth root, we'll need only 4 2's, so we'll keep 6 as it is. And the next one here we have 3 fourth root of 2. That means the 3 which is outside, we'll keep it inside the root and it will be 4 3's. 1 2 3 4 and 1 2 is already there. So now we'll multiply it. 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 into 6 is 96. Root 96. Next we have 3 3's are 9, 9 3's are 27 and 3 2's are 6. 27 into 6 we have root over 162. So here we got 162 is the largest and 96 is the smallest. So the descending order is 162 is greater than root over 96. Next question you will solve in the similar way. Since it is the square root, it's very easy to solve. Inside the root there are 2 7 and 1 3. And next inside the root there are 2 3's and 1 7. In this way you'll solve it and that's your homework. I think you can do it. Next, question number 15. Compare. We have to compare between the two numbers. Question number 1 is 6th root of 15 and 4th root of 12. 4th root of 12. So here you got the root is 6th and 4th. The root means the power will be 1 upon 6 and 1/4. We can write it as 15 to the power 1 6, 1 by 6 and 12 to the power 1 by 4. Now it has got the different power. We have to make these powers equal, and for that we'll take the LCM of the denominator of the powers, that is 6 and 4. So the LCM of 6 and 4 will have 2 3's are 6, 2 2's are 4, 2 1's are 2, so 4 3's are 12. So here we got the LCM 12. So now what we'll do is we'll multiply the denominators, both the denominators, to make it equal to 12, since we have to make the power equal. Here we got, in the first case, 15 to the power 1 by 6. The denominator is 6. We have to make it 12. So for making 12, we have to multiply 6 by 2. 6 into 2 makes it 12, and by the same number we'll multiply the numerator. And here, in the case of 12 to the power 1 by 4, denominator is 4, we'll multiply by 3, it will 4 3's are 12, and we'll multiply by the same number in the numerator. Here we got 15 to the power 2 by 12, and next 12 to the power 3 by 12. Now you can see that we have made the denominators equal, but the numerators are not equal. So for making them equal, we'll take the numerators inside the bracket. Now we'll have 15 square, 2 will go inside, 15 square whole to the power 1 by 12. And next we have 12 to the power 3, or 12 cube, since 3 will go inside, 12 cube whole to the power 1 by 12. Now we have made the powers equal, and now only we can compare these two values. So we'll have to find 15 square value and 12 cubes value. So 15 square equals to 225. Here we'll write 225 to the power 1 by 12, and 12 cube, if you multiply 12 three times, you'll get 1728 whole to the power 1 by 12. So comparing these values, we got that 12 cube, that is 1728, is greater. So we'll write our answer in ascending order, that 4th root of 12 is greater than 6th root of 15. Next question we have root 24, that is square root. And for square root, we'll write 24 to the power 1 by 2, and cube root of 35. For cube root, we'll write 35 to the power 1 by 3. So we'll do the LCM of 2 and 3, multiply with the denominators, and we'll find the answer. That's your homework. Next, question number 16. Insert two irrational numbers between 5 and 6. We have to insert the two irrational numbers which lies between 5 and 6. So 5 we can write as root over 25. Why? Because square root means it has a pair of 5 inside. So we can write 5 as square root of 25. In the same way, 6 we can write square root of 36. 6 are 36. So between root 25 and root 36, there are many irrational numbers. They are 26, root over 27, root over 28. There are many. So you'll write only 2. So you can write root 26 and root 27 are the two irrational numbers between 5 and 6. Next question. Question number 17. Insert 5 irrational numbers between 2 root 5 and 3 root 3. 2 root 5, we can write it as, since it is a square root, so inside the root there will be a pair of 2. 2 into 2 into 1, 5 is there. And 3 root 3 we can write as 3 into 3 into 3. So by multiplying, we'll get 2 2s are 4, 4 5s are 20, and 3 3s are 9, 9 3s are 27. So between 20 and 27, you have to find 5 irrational number. It's very easy. It's 21, 22, root 23, and so on. In this way, you have to find the 5 irrational numbers. Next question, question number 18. Write two rational numbers. Now here you have to write the rational numbers, not the irrational. So here you've got root 2. You should know the value of root 2, or otherwise use your calculator and find it. So the value of root 2 is 1.414, and the value of root 3 is 1.732. You can consider this value up to 1 decimal point as 1.4 and 1.7. So between these two numbers, the rational numbers are 1.5, 1.6. 1.7 we cannot count since it is here. So the two numbers are 1.5 and 1.6. Otherwise, you can write it as, there are numbers between 1.5 and 1.6 also. That is 1.51, 1.52, and so on. So in this way, you can write the rational numbers between two irrational numbers. Next, question number 19. Write 3 rational numbers between root 3 and root 5. So you have to find 3 rational numbers. So the value of root 3 is 1.732, and the value of root 5 is 2.1. So between 1.7 and 2.1, the numbers are 1.71, 1.72, 1.73, the three rational numbers. Question number 20 is the last question of exercise 1b. We have to simplify. Number 1 is fifth root of 16 into fifth root of 2. See the roots. Both the roots are similar roots, that is fifth roots. So we can make one root for both the numbers. These are same, so make it one root, that is fifth root. And under the fifth root, write the numbers which are inside the root, that is 16 and 2. 16 into 2. Now we can break 16 into 2 into 2 into 2 into 2. 4 2s. 2 2s are 4, 4 2s are 8, and 8 2s are 16, and 1 2 is here. Now since it is a fifth root, we have to find the 5 pair of 2. So here are 5 2s. So 2 will come outside the root, and this is our answer. Next question, question number 2. It's fourth root of 243 divided by fourth root of 3. Here also the root is similar, so we'll make one big root for both and write the numbers inside the root. 243 divided by 3. So divided by 3 we'll get 3 8 are 24, 3 1s are 3. So we'll get fourth root of 81. So we can write 81 as 3 3s are 9, 9 3s are 27, 27 into 3 is 81. So here we got 4 3s and it will come outside the root, and it is your answer. Next, question number 3. We have to multiply both the numbers. Since it is a bigger number, we have to first write 3 and multiply it to 4 plus 7, and by root 2 we'll multiply the same number, 4 plus root 7. So we'll write 3 plus root 2 into 4 plus root 7. So let me change the color to make it clear. So first we'll write 3 and multiply it to 4 plus root 7, and then we'll write 2 root 2 and then multiply it with the same number. So 3 into, we'll write 4 plus root 7 and plus root 2 into again 4 plus root 7. In this way it will become easier to multiply. So now 4 3s are 12 plus, now since it has a root 7 and 3 doesn't have root, we'll multiply the number with the number, that is outside the root there is 1. So 3 1s are 3 into root 7 plus root 2 and 4. The same way 4 1s are 4 and root 2, 4 root 2, plus into plus is plus, plus. We'll multiply the roots. 2 7s are 14. So look here, is there any number that we can add, subtract? No, nothing is there. So we'll keep it as it is. See, there is number 12, but there is no number to add or subtract with it. And there are roots, but they are not similar, so we cannot add and subtract. So that's the answer. Next, question number 4. You can see that it seems like a minus b whole square. It is a square plus b square minus 2ab. So here a is root 3 and b is root 2. So applying this value will solve this question. So root 3 minus root 2 whole square equals to root 3 whole square, and b is root 2 whole square minus 2 into root 3 root 3 into root 2. So we'll have 2 will cancel the root 3 plus 2 will cancel the root 2, and we'll multiply the numbers. 2 ones are 2, 2 ones are 2, and inside the root there is 2 3s are 6. So root 6. Add the numbers. 5 minus 2 root 6. So this is your answer. So this was the last question of exercise 1B. In the next video, we are going to solve the questions from exercise 1C of this chapter. Thank you for watching. For more videos, please don't forget to subscribe to my channel.